Teledyne FLIR Defense has unveiled a new autonomous drone platform called SkyCarrier, and it could significantly change how drones are deployed in both military and civilian operations. Revealed at the DSEI exhibition in London, the system is designed to launch, recover, protect, and manage drones with minimal human involvement. SkyCarrier works with the company's SkyRaider and SkyRanger drone systems and can be mounted on land vehicles, ships, or fixed locations. What makes it stand out is its ability to automatically launch and recover drones, even while the platform itself is moving. Whether mounted on a vehicle driving across rough terrain or a boat navigating choppy waters, the system is designed to keep drone operations running smoothly. The platform uses a rugged protective container that keeps the drone safe when not in use. When it's time to fly, the container opens and unfolds an advanced launch and landing pad. This pad helps guide the drone during takeoff and landing, making the process highly reliable even on uneven ground or moving platforms. Using visual navigation aids such as infrared beacons and machine-readable markers, the drone can find its way back and land precisely without requiring operator control. One of the most impressive features is its ability to compensate for movement and tilt. The system can adjust for angles of up to 20 degrees, allowing drones to safely land on both stationary and moving platforms. The container also shields the aircraft from environmental hazards such as debris, vegetation, and harsh weather when it's not flying. SkyCarrier supports both traditional free-flight missions and tethered drone operations. It also handles battery charging and thermal management automatically, enabling long-duration remote deployments in challenging environments. This means operators can leave the system running with very little direct supervision. Another standout capability is its Follow Me mode. Drones can automatically track and return to designated vehicles, personnel, or locations. The platform also introduces autonomous in-air replacement, or AIR, which allows a single operator to oversee up to 16 drones. As one drone nears the end of its mission, another can automatically take over, creating continuous surveillance coverage without interruptions. The system is also designed for difficult operating conditions. It can function in GPS-degraded environments, and even in situations where radio transmissions must be minimized. Using computer vision, dead reckoning, obstacle avoidance technology, and jam-resistant navigation systems, SkyCarrier can continue operating when traditional navigation methods become unreliable. For missions requiring longer endurance, the platform supports extended capacity batteries that allow drones to remain airborne for up to 45 minutes, while carrying payloads weighing as much as 2 kilograms. Real-world testing has already demonstrated the system's capabilities. SkyCarrier has been successfully deployed from fast attack boats, rigid inflatable boats, and ground vehicles traveling over rough terrain at speeds of up to 50 kilometers per hour. These trials showed that the platform can reliably launch and recover drones in demanding operational environments. The platform can also carry a wide range of payloads, including daylight and thermal imaging systems, targeting equipment, electronic warfare tools, signals intelligence sensors, remote chemical and biological detection systems, and communication relay equipment. This flexibility allows it to support missions ranging from intelligence gathering and surveillance to border security, convoy protection, hazardous materials response, and communication support. With its combination of autonomous launch, recovery, fleet management, and advanced navigation capabilities, SkyCarrier represents a major step toward fully automated drone operations in some of the world's most challenging environments.